Okay. Riemann sums are about estimating area. So you can solve a definite integral by finding area. So just because an integral is a way to find an area doesn't negate all the stuff we've already learned about finding area. Okay? So if I gave you the function negative 2x plus 6 and you're like, I don't want to do that integral, that's fine. You guys, if I'm looking at between 0 and 3, can I find the area of this triangle between 0 and 3?
Yeah.
What is it?
3 times 6 times 1/2, which is
3 times 6 over 2, and I know that the value of this integral is 9. We good? And I don't know about you guys, but that feels a heck of a lot easier to me. A heck of a lot easier to me than doing the integration. So there's value in considering what the graph looks like. What about from 3 to 5? When we think about how the Riemann sum and the integral calculate area, it was the value of the function times dx. Times delta x, yeah? Okay? And so as we're thinking through, between 3 and 5, what can we say about the value of the function? It's negative. So the integral will be negative, but it will still be the area. So to find this one, I'm going to say, to find this area, we're going negative. And let's see, that looks to be 2 times 4 over 2. So negative 4. So what would the net area be? 9 plus negative 4, which is 5. But if I ask you for the total area, you'd absolute value that, and it would be 13. Feel okay? All right. Now, it can be useful when we have things that are challenging to integrate. Understanding that integrals and area are the same thing can be quite helpful. For example, can we integrate 3 minus the absolute value of x between negative 3 and 3?
no, because it's going to be the same thing.
It's not differentiable, yeah? Do you guys see what I'm saying here? There's no function whose derivative is the absolute value. Are we good?
There'd be no change anyway, because if you plug in 3, negative 3, you get the same thing.
Well, the value of the function, that just tells you that the slope would be that the slope between negative 3 and 3 would be 0. You guys, what does the function 3 minus the absolute value of x look like? It's upside down v, yeah? Absolute value is, and it kind of would go, and what are the values of these intercepts?
0, 3.
So 0, 3, but also then 3, 0, yeah? So even though I don't know how to calculate this integral mathematically, or algebraically, or however you want to say it, analytically, can we calculate this integral geometrically? Well, it's a triangle. This is 6. This is 3. 6 times 3 over 2 is 9. So that this particular integral would equal 9. Yes? And we guess is what this function looks like.
Isn't it it's like this?
Not if the x is squared.
Oh, yes.
X squared is like this.
Oh, dear.
Hey guys, if I gave you this equation, what would you tell me?
Circle.
Circle with a radius of? Nope. 8. Because it's our x squared plus y squared equals r squared, right? If I solve that for y, I would do 60. First I would subtract the x squared, then I would take the square root. This is the top half of a circle. Really, y would be plus or minus. So if I threw in the negative, it would complete the circle. That'd be good. And with a radius of 8. Yeah? So between negative 8 and 0, and basically I'm trying to calculate this area. Now, I don't know how to integrate the square root of 64 minus x squared. I don't, but I know that the area from negative 8 to 0 of that would be pi r squared, which is pi times 8 squared over 4, because it's 1/4 of a circle. So that works out to be, I don't know. Let's see, that's 64 divided by 4 is 16 pi. So I don't know, like 50.26. If anyone wants to check me on that. There's certain pi.
7,
It was 2.7?
if you round.
265.
They lied to me this morning. They told me I was right when I said 2.6. Everybody good? All right, so how would that change if I'm going from negative 8 to 8?
You would divide it by 2 at the end instead of 4.
Divide by 2. Yeah, I would just take that answer times 2, but whatever you guys want to do is fine. And that I bet you get 100.53.
531.
531. That's close. It's a little bit impressive. I used to have a lot of the multiples of pi memorized. They came up so often. Because my teacher would say put it in terms of pi, and I would just put the whole thing in my calculator and then learn the decimals and stuff until I learned it. Well, that seems like a good place to stop, doesn't it?